Today we're going to be rebuilding the Mac OS dock with the magnification effect using Framer Motion. And I just love how simple the final code is, how much bang for buck you get with the techniques we're going to learn. And so I think you're going to like this one. If you want to check out the code, go ahead and look in the description for a link. But otherwise, let's get right into it. And I want to start by looking at this static mockup we have right here and just talking about how we're going to pull this off. You know, when I first started building this, I was thinking about all sorts of stuff. You know, if we popped open the inspector here and just grab one of these icons, you know, my first thought was, well, of course we're going to have to scale this up, right? So if we were to add some scale to this, that's one way to make these circles bigger and smaller. But if we mouse over this and scale it up, well, now we're going to have to push these to the side, right? And so maybe we're going to have to add some transform in the translate X position and kind of move these left and right like this. But then we're also going to have to grow the background dock area as this happens. And it turns out that a much simpler approach to this problem is to just change the widths of these circles and everything kind of takes care of itself. So let me show you what I mean. I'm going to refresh, grab one of these circles, and we see right now they start off at 40 pixels wide by 40 pixels tall. So if I come here, grab the width property, make it 40 pixels, and just start increasing it, look at what we get. We get all the nudging behavior for free. The background dock changes size to accommodate it just using flex layout and CSS layout. So this turns out to be performant enough for this technique to just animate the width, and it makes the final code much, much simpler. So that is exactly what we're going to do. We're going to be animating the width of each one of these circles as we mouse over it to pull off this magnification effect. So to start, we need to know where our mouse is. So let's come here, close this and refresh, and take a look at what we have. We've just got some flex layout here to lay out our dock, and our dock is also a flex container with item center and a little bit of gap in between each one of these icons here. And then we're iterating over an array of 6 elements and creating a circle for each one of our app icons. So that's what we're starting out with. And now we want some way to get the mouse position whenever we're moving over the dock here. So let's come to our root div of our dock, and let's go ahead and add an onMouseMove prop, which will give us an event. And this event has a pageX property. So let's go ahead and make a new line here and console.log this. Come back over, pop open our console, and look how easy it is just to get the X position of our cursor. This is going to give us how many pixels from the left side of the page to our cursor. And we can see here right at the edge, it's about 140 pixels. And if we kind of measure this with the screenshot tool, we're going to see 140 pixels. So that is giving us that nicely. And now that we have this, we need some way to store it. And we could use React State, but if you've watched my Framer Motion content before, you'll know that because this updates so frequently, using a primitive like Framer Motion's motion values is a better fit here because we get to avoid triggering re-renders in React. So let's come over to our dock. We'll use motion value. This is going to be where we store our mouse X position. And let's just default this to 0. And then whenever we move our mouse, we're going to set our mouse X to e.pageX, just like that. And so now, as we move, we should be updating that motion value. And to get some feedback to see if we actually are, let's go ahead and turn our app icons here into a motion div. And this is going to let us use the style prop. And we can just set something like the X property to our mouse X. And look at that. Now we're tracking the mouse position. We can update any style prop using that. That's a little silly. Of course, we can come here and change this to width. And this is even more silly, but you get the idea. As we move the mouse over the dock, we can adjust the width of our app icons. But we don't want these widths to just be a one-to-one transformation of the pixel values in our screen, right? We want some mapping from the pixel values to the desired final width of the icon. Well, Framer Motion has something called useTransform, which lets us do exactly that. So we'll create a new width variable, and this width is going to be a transform of our mouseX motion value. And here we give it a domain and a range. So let's say as the mouseX goes from 0 to 300, we want our app icons to go from 40, which is their original size, maybe up to 80, something like that. And we can go ahead, grab use transform, refresh, and now we can use this width down here on our style tag. So we'll just use the shorthand. And if I come over here, now we have this kind of mapping, and you can see we already start out at about 100 pixels right here. But as we get up to about 300, that's when we hit 80 and then we stop. And in fact, this transform can take more than just 2 elements in the domain. We could go up to 300 for the first interval and then have a second interval where we go up to 600 pixels. And then we can map that to 2 intervals in the range. So first we want to go from 40 to 80, and then maybe we want to go back down to 40 pixels. And so now if we mouse over this, we see they grow and then they start shrinking again. So now you're getting the idea of how we can translate the raw mouseX position into a range that is meaningful for kind of the width transformation we want to pull off. So that's pretty cool. If you've never seen motion values or used transform before, they're an awesome part of working with Framer Motion. So we have our width kind of moving with the mouse position, but all of the app icons are moving together, and we don't want that, right? We want each one to move as our mouse gets close to the center point of each one of these circles. So right here, where we're rendering each one of these, we actually want to look up and measure the position in the DOM of each one of these app icons. So let's go ahead and grab this, and we'll make a new component. We'll call it app icon, where we return this markup and replace this with an app icon. And this component is going to give us a nice little place to do that measurement work. We'll go ahead and key this by the index, get rid of it there. And up here where we're transforming the mouse position into the width, let's just bring this width down into our component so that each app icon can calculate its own width. And this width is a function of mouseX, which is owned, kind of lives up here in our doc. Let's go ahead and pass that right into our app icon. mouseX equals mouseX. We'll expose this as a prop. And let's go ahead, give this a type of motion value. Just like that. So we should have the same behavior as before. Looks like we do. But now, instead of making the width a transformation of the mouseX position, which is the same for all of these, we want to make the width a transformation of the distance between the mouseX and the center of our icon. So how do we find the center of our icon? Well, if I were to grab this element right here in the dev tools and then pop open the console, we'll see that I can actually grab this with $0. This is a little Chrome DevTools shortcut, and we see that gives us that element right there. And you may be familiar with a method called getBoundingClientRect. So if I invoke this, we're going to see all sorts of useful information here. Its width, its height, where it is in the DOM, and there's this X property, which is 103, and we can see that that corresponds similarly to the page X position of how many pixels the left-hand side of this circle is from the left-hand side of the page. And we can see the 103 right there. So this is going to give us the position in the DOM of each one of these circles, right? And we're already storing the X position of the mouse in this motion value. So if we subtract the X position of each circle from wherever our mouse is, we're going to get the distance from the mouse to each app icon, right? So let's come here and create a new property called distance. And this is going to be kind of an intermediate transform. So we'll use transform again. This will take mouseX. And instead of using this syntax where we map a domain to a range, we'll create a function. And this function takes in the current value of whatever motion value we're passing in right here. So let's go ahead and log the val. And I'll go ahead and comment this one out so we can just see. And if we clear our console, we're going to see that being logged right there. But we want to subtract from that the X position of each one of these elements. So we need some way to get a hold of this div. We can just use a ref to do that. So this is going to be a ref. We'll slap this onto each one of these app icons. We'll pass a null here since we're attaching this to an element. And let's go ahead and log the bounds of this element right here. Log ref.current. And this could be undefined. And we should be getting autocomplete here. We need to tell this that this is going to an HTML div element. And now bounding client rect is showing up just like that. So I'm going to save that and refresh. And we're going to see a lot of logs because we have 6 icons. Let's just come up and change this to 1. Refresh. And check this out. As we move the mouse, we get the updated mouse position, but we also get the rect for our icon, which has this X property right here. So if we store this into a bounds variable and subtract that bounds.x from our mouse position, we'll check this out. Now, as I move across the icon, right when I get to the left-hand side, look, that value is 0 because the distance between our mouse cursor and the edge of our icon is 0. And then it's positive when I move to the right, and it's negative when I move to the left. Now, that's pretty cool, but we don't actually want the left-hand side of the icon to be 0. We want the middle to be 0. So we need to also subtract half of the width. And remember, that comes from bounds.width. That's another property off of our DOM rect. So we'll just subtract width over 2. Check this out. And now, right when we're in the middle, we get 0. And when we go left, we're negative. And when we go right, we're positive. So that's going to give us the distance from the mouse to the middle of this app icon. Now we have some TypeScript errors here because this can be undefined if our ref is null. So let's come here and handle the case before React has had a chance to set the ref. We'll just create kind of a null object with X of 0 and width of 0, just like that. And this should still work out just fine. So pretty neat. We now have the distance. And when we use the function version of useTransform, we just return this. And what that does is give us a new motion value that we can use to get our width. So we want the width to be a function of the distance from the mouse to our center point. And let's just pick this. Let's say we'll go from negative 50 pixels up to 0 and then up to positive 50. Give that a save. And now look at this. It grows, it hits the maximum width when we're in the middle, and then it starts shrinking again. And if we come back and make 6 of these icons, look at that. Pretty neat, right? Now this threshold's a little bit small. Let's go ahead and make this a little bit bigger. Maybe 200 pixels out in either direction. And now you're starting to see how exactly we're gonna be able to pull this effect off. So this is pretty neat. If you've never kind of done this series of transforms, it's a really popular pattern in Framer Motion. We get the mouse X from the dock. We transform that into a pixel distance from the origin of each app icon. And then we define the width as a function of that distance. And this is kind of where we get to have a lot of fun and really fine tune this animation. But that is the basics of this technique. So this is definitely on its way, but we still have a few things to fix. First of all, when we move our mouse off the dock, we're not kind of resetting these icons at all. And second, if I go ahead and refresh, we're actually going to see they start off as too big and they only start resizing once we mouse over. So let's take the second case first. Let's handle the initial render here. And this has to do with the fact that we're using 0 for kind of the null state or the initial default value of mouseX. And if we pass 0 through here, we're kind of right in the middle of this threshold and we're getting that bigger size. So when I first did this, I thought, maybe we'll have a new piece of React state is active, is inactive, and we'll turn it on and off when we mouse into the dock and then out of the dock, and then use that to control whether we apply the animations. But I really love this API, this useTransform API. It just takes, a pure range of numbers. And so I thought, why don't we use infinity, which is a number in JavaScript, it's kind of a global constant. And infinity will definitely fall outside of our domain, and that will kind of reset the sizes back to their initial size. So let's just try that. If we say infinity right here, give this a refresh, we'll look at that. We're going to see that the initial render is correct. Infinity gets passed through to mouseX. And then when we calculate the distance here, we're basically going to say infinity minus whatever these are, which is still infinity. Handy little property of infinity. And so we're definitely going to be outside of this positive and negative 200. So that's pretty cool. And now to handle the case where we mouse out of the dock, let's just basically do the same thing. So whenever we mouse out, we'll kind of reset mouseX to this null value. And we can do that right here with on mouse leave. We'll just go ahead and mouseX.set back to infinity. And let's just make this one line right here. And now with any luck, whenever we leave, we kind of reset it. So that's pretty nice. Initial render works great. And so now we're in business with one final exception. And that is, even though our logic seems right, the whole thing just feels really stiff. And, of course, when we come here, this just snaps. Ideally, this would be animated. Check out how easy this is. Right now, this width is a pure transform of distance. So it's kind of like a synchronous width. It happens right away. So let's rename this to width sync. And let's create a new width variable. And instead of using a transform, I'm going to use a spring from Framer Motion. And we're going to transform this sync width into a spring width. Look at that. How easy is that? All of our logic works great. We did it all with basically no animation. It's just following the mouse as a pure transform, synchronously updating, and then we can just animate it this easily just by passing this into useSpring. Now, of course, this is pretty crazy here. There's a lot going on, but this is actually very easy to customize with some options to use Spring. Now, Spring transforms in Framer Motion have three properties. The first is damping, which defaults to 10, mass, which defaults to 1, and stiffness, which defaults to 100. So if I were to add those, we'll see the same thing here. But maybe these icons feel a little bit heavy. So instead of 1, let's bring this down to 0.1. Now they already feel a lot lighter. Maybe the damping could go up a little bit so there's not quite as much. Or maybe down to 15, something like that. And if we were to increase the stiffness here, maybe to 200, something like this feels a lot better. And to fine tune this, let's actually fix the fact that these are growing kind of in the center of the dock, but in the Mac OS dock, they grow up, right? They're kind of aligned to the bottom. And that's from this item center up here. This is just a flex layout, so we can change this to items end. That should put them at the bottom, and then they should grow up. And let's add a little bit of padding to the bottom here. Padding bottom of 3 to offset them kind of perfectly inside of our 64 pixel dock. So now this is starting to look much more like the Mac OS dock. Let's go ahead and grow this. Instead of 80, let's maybe make it, 100. Can go crazy with this. But this is where it's kind of fun to play around with these values. And you can see these obviously have a huge effect on the look and feel of this. If we go back to the default Spring, maybe this works for your app, I'm not sure, but pretty amazing how easy this was to turn this from the logic, once we got the logic into an animation. And again, because we're using motion values for this, this is an animation, and so motion values are great for that. If we were to drop in a log of render right here, we're going to see each one of those components renders once. And then as we mouse over, we're not seeing any more renders. So this is going to help, prevent unnecessary renders in your React component, keep it performant. But if we go back to our config, you can really go to town with this and tweak this and change how it feels and how it looks. And if we come off of the dock right here, we get that animation because of the spring. As we move it, we get that animation. So pretty neat stuff. Really just a few things to understand. I wanted to make sure to explain those transforms if you've never used them before. But if you look at our final code, I mean, this is it. This is the whole thing right here. It's really just creating a motion value to track our mouse position, updating that when we move across the dock, and then calculating the distance from that mouse position to the center of each one of these icons using a transform, and then creating a new variable that's derived from that distance. Here's the domain whenever we're within 200 pixels. This is super easy to change, and this has a big impact on the look and feel. Let's make it 300, and now they're going to grow a lot more. Or we could make it 100, and it's going to be more narrow, really easy to change. And then finally, just turning that into a spring with useSpring. So a lot of cool stuff here. And again, very high yield for basically the 3 important lines of code that we needed here and here to get this animation to work. So hope you learned a lot from that, like that. Maybe you can figure out a place to use this effect in your app. I think it's really fun, really kind of delightful when you stumble across something like this on the web. Make sure to check out a link in the description for all of this code up on Build UI. Let me know if you have any questions, and otherwise, I'll see you next week. Bye-bye.